Hello and welcome to this presentation brought to you by the Mapping and Benchmarking Annex of the IEA 4E Implementing Agreement. This presentation is regarding the energy efficiency and policies that are in place in several countries around the world regarding refrigerated retail display cabinets. This is a summary of the results of a report which was published on the IEA 4E Mapping and Benchmarking Annex website in December 2012. The first section of the presentation will clarify exactly which products are within scope. We will then move on to discuss the data sets that were collated as part of the research, going into some detail about that, the nature of the data sets. We'll then talk about the metrics that are used to define energy and energy efficiency of these products. We'll talk about the test methodologies that are used in the various countries to determine energy efficiency and energy consumption. And then we will talk a bit more about the comparability issues. This is quite a complex product area, and there are quite a number of issues associated with the analysis and rendering the data comparable. And I hope you'll bear with my description of that, because it does have a bearing on the how the results are interpreted. So we'll then talk a little about the policies that are in place in the various countries, and then we'll move on to the results of the data in terms of the types of product that are on the market in these countries, and then we'll look at the energy efficiency and energy consumption data that we've determined and how that varies over time. And we'll finish with a few observations and key issues drawn for the perspective of policymakers in this area. Now, the subject of the analysis were two particular types of retail display cabinet. Display cabinets used in retail can take a very wide range of different types, and we picked on two particular types that we felt were reasonably ubiquitous in the countries that were taking part, and also were the products for which data was available. Data availability was not great for many of the types, and so we picked a couple that we were confident would have sufficient data. So they are, as the image on the left of this slide shows, the vertical chilled temperature cabinets that have glass doors, often used for the display of drinks in retail premises. So these, the image you see there has two doors rather. We placed no restriction on the number of doors, but they had to be doors in the vertical plane. The second type that we focused on is the horizontal freezer as used for ice cream merchandising, either with or without a lid, but of the type for which the product is visible from the outside. An important point regarding the scope is that we only looked at integral display cabinets, which are the type for which the refrigeration pack is built into the cabinet itself. We excluded products with a remote condensing unit. So in common with both of those types of cabinets, they are designed for a customer to see what's inside the cabinet even when it's closed through a transparent door or an opening, but in the case of these cabinets, only the horizontal freezer cabinets had some types that were of the open type. On this slide there are just some more images of the types of product to be included. This slide confirms what types of product are included and excluded from the two categories. A couple of points to emphasize here. The temperatures, storage temperatures which are included, had various names in the different country data sets. Chilled / medium temperature for the vertical glass door cabinets, and the horizontal frozen cabinets, some had a particular ice cream temperature within the regulation or within the test methodology. Some simply called it frozen or low temperature. But all of these factors had to be adjusted to render them comparable, and we'll come on to that in a second. The datasets that we received from the participating countries, which were Australia, Canada, the UK and USA, these datasets contained a total of around 3,000 different cabinet models. 3/4 of the data was regarding the vertical glass door chilled cabinets, and only 1/4 related to the ice cream display cabinets. The USA data, we actually had 2 data sets from the USA. One was for the Energy Star label program, which includes only the better performing products on the market. And we had a data set from California. As a note on that particular data set, California does have minimum requirements for the state, and so that would influence the level of performance you'd see there compared to the rest of the USA as a whole. The data sets we received from the UK was one from a endorsement scheme which is run in the UK, which allows capital allowances for those purchasing cabinets that meet a certain efficiency criteria, and so that dataset represents only better performing products on the UK market. It is a voluntary scheme, of course. And we also had some data from an independent test house, and that was a much smaller data set, and we'll talk a little more about the implications of that as we go through the data. The data we had covered the period from 2006 to 2011, and none of the data was sales weighted, so it was just lists of products available at that time, or the products that were available in the data set. So firstly, looking at the glass door chilled cabinets, you'll notice in the top left hand corner we have an image of that type. As we're dealing with the 2 types of cabinet, check the top left hand corner to be sure which type of cabinet we're talking about on any given slide, in case it's not otherwise clear. So we had a lot of variability in the number of products included in the datasets, ranging from a few tens of products up to nearly 600 for the Australian dataset in particular, which was the largest dataset of this type. Datasets or data bins of any particular year for any country that had less than 14 products in them were excluded from the analysis as being not reliable averages for that year. And indeed the UK dataset was quite weak in that respect, from both the test house and from the enhanced capital allowance scheme in terms of the chilled vertical glass door cabinets. Looking at the ice cream cabinets, the vertical scale of this graph is the same as the previous one, so immediately you can see that the numbers of products were very much lower, but there was less variability between the data sets perhaps, and once again those with less than 14 in any given year, those particular years with less than 14 were excluded from the analysis. Australia once again had the highest count of products in that dataset. And whilst the UK dataset did have quite a significant number more than it did in the UK vertical chilled set, it's still a weaker dataset compared to the others. So the data sources are summarized in this table. The data sets within this analysis are allocated a quality grade as with all of the analyses that we do in this mapping and benchmarking annex, there are three grades of quality. Firstly, robust data, then indicative, and then illustrative are the three quality grades. Robust data would basically be that which is sales weighted, so accurately reflects the sales weighted performance of the market. And robust data would certainly also be of very well understood sources. The test methodologies would be known and understood, and the data would be highly reliable as an indicator of the performance of the whole market. The next grading would be indicative, and this would be where the data set is representative of the majority of the market, but possibly not all. Or indicative can mean that there are some assumptions involved in the analysis of the data which bring an element of uncertainty into the results. But we would believe that indicative is quite reasonable from which to draw some conclusions. The third quality rating is illustrative, and that's where we know that a data set is only representative of a part of a market perhaps, or if there are some fairly significant adjustment factors involved in rendering the data comparable between countries. And that's really why the data sets in this analysis have all had to be called illustrative, because there are some quite significant adjustments, some of which are not based on particularly robust empirical data, and we will talk about that in a moment. But as you can see, the count of cabinets included in the data sets varies from only 75 in the case of the UK test house data set up to 1400 for the Australian data set. The metrics used in the various countries to indicate energy consumption are all kilowatt hours per 24 hours. That's a fairly universal metric for consumption. But the efficiency metric is where you start to see some significant divergence of approach. The EU tends to use a total display area for retail display cabinets as part of its metric, and the Australian system has followed largely the EU and also adopted the kilowatt hours per day per square meter of display area. Whereas the USA and Canada has pursued much more, historically certainly, a volume-based efficiency metric. So it's kilowatt hours per day per cubic meter or per cubic foot of cabinet. More recently, since 2012, the US system, the US regulation, has moved over to adopt a display area based metric for the ice cream frozen cabinets, but the vertical glass door cabinets are still based on a volumetric efficiency. And the test methodologies in use do vary quite significantly in different ways between the different countries and regions. This slide has highlighted 4 of the main parameters that vary around the different test methodologies. There are many other aspects in which the test methodologies vary, but the others are of much lesser impact on the efficiency. I mean, there are things to do with how the volumes are calculated, how the display area is calculated, and indeed for the product loading during test, etc. The ones highlighted on this slide are the main ones that affect the energy measurements most significantly. So the normalization was needed in order to render the data produced under these different test methodologies comparable. So data tested to the Australian standard had to be compared fairly with that from the EU or the US standard. and that proved to be a complex process of adjusting for these various differences, differences of so many different types, and the nature of those differences, how they impact the energy consumption, varied significantly. So basically we had to follow a process of normalization, and what we did was to convert all of the data results to be as if they were tested to a particular set of rating conditions, and those rating conditions that were selected are highlighted in red on this slide now. So we chose to adjust as if the lighting had been left on for the entirety of the test, so the EU test measurements had to be increased by a factor that allowed for that additional lighting heat load. Similarly, the door openings, which are carried out during the testing, were adjusted, the results were adjusted as if they had been tested with a total number of door openings that the total 612 seconds open per day. The temperatures, we chose the 5.5 degree centigrade storage temperature as the standard for the vertical glass door cabinets. So those tested under the ASHRAE standard at 3.3 had to have the energy figures increased by a proportion as if they were tested at 5.5, and etc. through the other conditions. So we'll look briefly at the nature of those adjustments now for each of those aspects. So this slide summarizes the normalization process. Firstly, the lighting adjustment had to compensate for the heat load that was generated by the lighting within the cabinets. This was complex to estimate because lighting data was not given for all of the cabinets, and so estimates and extrapolations were necessary, but it made a difference of about up to 4% change in the energy consumption as a result of the adjustments for lighting during testing. The door opening adjustments, we did have a limited amount of empirical evidence, and that resulted in a 16%, maximum of a 16% adjustment to some of the data points. The product temperatures at which the contents were stored during test resulted in an adjustment of up to 11% of some results. And indeed there was also the ambient temperature during test to be adjusted for, and this is where quite a significant percentage adjustment was necessary. Some of the ambient temperatures were quite different to the one we adopted as the base standard, and that resulted in up to 25% adjustments in some cases for some of the test results. And because of the permutation of all of those different adjustments, we could only allocate an illustrative quality grade to the data that you'll see in these slides. Finally, regarding the analysis process, I hope that you are bearing with us on this, because there are some significant issues associated with the comparability of data which need to be borne in mind when looking at the results. In summary, the glass door cabinets, the issues need to be borne in mind are particularly the UK dataset has a quite a weak basis, a low count of products, and indeed the ECA dataset only includes the better products on the market. For the vertical glass door cabinets, lighting and door opening adjustments were required for most of the data, resulting in a 10 to 20% adjustment. And indeed, the data sets did not always include volume and display area data for a given cabinet. In fact, rarely did we have both pieces of data regarding a given cabinet, and that also restricted the comparability of the data and restricts the quantity of data that can be considered in any one comparison. And the main issues regarding comparability of the ice cream cabinets are firstly that there was not a specific distinction for ice cream type cabinets in some data sets, and this could possibly have had some impact in the refining of the data sets to make sure they only include the right products. Some temperature and functionality issues were not as clearly defined in a few data sets, and it's possible that there were some products that didn't fully meet the intended description, and I will highlight one of those issues that's evident on one of the later graphs. Luckily, there is a lower impact as a result of the door openings. The opening of a horizontal door in the top of one of these cabinets does not have such a big impact on the energy consumption of the units. And thirdly, another aspect of cleaning of the data sets with regards to making sure they include the correct products, the Californian data set did not have any field that differentiated the horizontal from the vertical frozen cabinets, and so it was not possible to be sure that we excluded all of the vertical freezers, and you'll see the results of that uncertainty in a later graph. So this slide summarizes the policies that are in place. Basically, there are no mandatory energy labels on this type of product anywhere in the participating countries, although there is the voluntary Energy Star label for better performing products, which is implemented in the Australia, Canada and USA. There are and have been a set of minimum requirements for these types of products in all of the participant countries except for the UK, although in the EU now there is consideration of the possibility of future standards for these products, but it's not there at 2013. The scope of the minimum requirements and the levels of performance expected vary significantly, and we will look at that in a little more detail later on. The terminology, the definitions and the scope of these policies are complex and vary significantly between the different regions, and it was very complex to make sure that we were comparing similar policies and similar levels of performance for the products. And some of the things that vary between different countries include whether or not they include the with or without doors. Some have a static temperature test, some include also a pull down test where the cabinet has to bring the temperature of a introduced load within a certain period. Some policies have specific criteria for the ice cream type cabinets. Some simply put in place generic freezer cabinet requirements. And of course this is without even looking at things like the inclusion or the exclusion of remote or integral cabinets. So it's the policies and the test methodologies are highly variable and complex around the different regions. And this gives rise to some of the conclusions and recommendations that we make at the end of the presentation. It's worth pointing out that the stringency of these different policies also vary, and we will have some graphical display of that at the end of the presentation. So moving on to characterizing the types of product that were included in the data sets that we had. This is looking at the average capacity in cubic meters for vertical chilled cabinets. This graph does not display the Australian or much of the UK data because that was recorded in terms of display area, not volume. This is a graph that shows volume. The Canadian, USA, and both of the USA datasets show fairly similar average volumes of around 0.8 cubic meters, and don't show very much variation over time, although arguably the Energy Star dataset average volume has increased and could be associated with products that achieve better efficiency through larger volume. The UK dataset is very weak in this area, and I think the average there can be discounted as not comparable. The average lighting power included in the cabinets appears to have reduced since 2006, 30 to 40% perhaps between 2007 to 2011. And what we're seeing, the effect that is seen in terms of the lighting is that it will reduce efficiency, because the heat from the lighting will some of it will enter the refrigerated space, which increases the heat load. And what we are seeing though is a higher proportion of LED lighting, very high efficiency, low heat lighting is becoming much more common in the products. In terms of the energy consumption, kilowatt hours per day, this is looking at the datasets that we believe are fairly representative of their markets. We've seen a fairly static level of performance actually. Between 2008 and 2011, very little variation, and Australia, Canada and the USA, in terms of the Californian set anyway, are very similar at 6 kilowatt hours a day. If the individual product data is plotted on a scatter graph, this is what you see. We have the Canadian and the Californian data sets, which are those deemed representative of their markets. This graph is in terms of the volume of the cabinet against its consumption in kilowatt hours per day. There's no Australian data here because we had very little volume-based data for the Australian data set. There's a very clear proportional relationship between consumption and cabinet volume, and the shape of the data sets, the cloud of data you see there, is very much influenced by the minimum requirements in those countries. Here you see the US federal requirements in the dashed purple line, and the Canadian minimum requirements with the solid yellow line. The Energy Star requirements are shown as the brown chain dotted line lower down. The Canadian minimum requirements were actually updated in 2012 and moved to align the Canadian standards with the USA federal requirements, and so the data that you see for products above that Canadian minimum requirements line was from prior to 2012. We would now expect most of those products to be removed from the Canadian market. But the range of performance, the variation in the range of performance, is still quite significant. Indeed, before the change in the Canadian requirements, we were seeing a plus or minus 50% range of consumption. And indeed, even within the remaining data set, there's still a significant range of performance across the market and across all of the volume range that you see on this graph. If we look at energy efficiency, or specific consumption, I should say more accurately, kilowatt hours per day per cubic meter for the glass door cabinets, looking again at the data sets that are representative of their markets, we didn't have volume data again for Australia, so that cannot be shown. The performance for Canada was around 12 kilowatt hours per day per cubic meter. California appeared to be a little better than that, around 20% better than that, at around 10 kilowatt hours per day per cubic meter. It's fair to point out, as I mentioned in the earlier description of the caveats, there could be some differences in the types of cabinet included due to the, in some cases, lack of sufficient detail on the cabinet type descriptions. If we look also at the very best performing products in these data sets, we see a performance level of around 3 kilowatt hours per day per cubic meter from the Energy Star dataset, and the best in the Canadian and Californian dataset was 3.5 kilowatt hours per day per cubic meter. Now this slide looks at the ice cream cabinets, the ice cream frozen cabinets, and characterizes the average capacity of the units in cubic meters. This includes, or doesn't include, I should say, the Australian and UK ECA data because there was no volume data recorded in that data set, only display area. The Canadian and USA products have, in 2010, 2011, have reached a roughly equal average volume of around 0.35 cubic meters, which is half of that we saw for the chilled cabinets on average. The UK dataset is very weak in this whole ice cream cabinet area, and compared to the others, and there's a high variability due to the low count, particularly of those that had the volume data associated with them. The consumption in kilowatt hours per day of these ice cream cabinets is shown in this graph, and we do perhaps have a trend going downwards over the time, although the data sets of course are not particularly strong. There does appear to be roughly a 20% drop in consumption over a three-year period roughly. But we have to bear in mind that the mix of cabinets in each dataset may have changed slightly over that time, and we have had some variation in the average volume of cabinets over that period as well, which will slightly alter the trend that we see. Once again, we have a scatter plot here of the consumption of the cabinets against their internal volume. This shows a proportional relationship between consumption and volume, but quite a wide scatter of results. Once again, we do have data sets that are constrained by the mandatory requirements, and this is illustrating one particular area in which we were unable to be sure of exactly what data was included, because the Californian data set, which is the purple squares in this plot, that data set did not allow the differentiation of vertical from horizontal cabinets for frozen cabinets, and hence the Californian data set does almost certainly contain some vertical freezer cabinets, which will have a higher energy consumption because of the door openings during that period. Will, of course, during the test period, will have resulted in loss of cold air and higher energy consumption. In 2012, the Canadian minimum requirements were adjusted to align with the US federal requirements for that type of cabinet. The US Energy Star requirements are shown to be quite stringent actually for these products, with the lower dashed line at the bottom. We do see in these data sets a quite significant range of consumption from best to worst, plus or minus 50% or so. Although I think it is fair to point out that, of course, the higher energy consuming products in this scatter may of course be some of those vertical freezer cabinets, and so the variation in consumption of the horizontal cabinets will be lower than is indicated by the extent of vertical extent of data in this chart. This is a plot, finally, of some of the Australian data, which is done in terms of the display area, which is the horizontal axis there. The other data sets did not have display area data included in them and so could not be plotted on this chart. We're seeing a lot of scatter in this data set. We do see a proportional relationship between consumption and volume, but there is a very significant scatter, and that would imply that there's probably a mix of different types of cabinet included. We did do some spot checks of the data set, but the products that we identified to check on did appear indeed to be of the correct type, the horizontal ice cream freezer type, so we were unable to explain why there's quite this much scatter in the data set. If we look at the efficiency of these ice cream cabinets, or their specific consumption in kilowatt hours per day per cubic meter, we see figures around 25 kilowatt hours per cubic meter per day. I wouldn't try and imply too much into the apparent trends we might see there. I think we do have some changing scope, changing samples within the data sets here. So we picked out some key issues for policymakers, and I think firstly we would appear to have evidence that there is scope for improvement in efficiency for each of the cabinet types, but of course this may have cost implications for achieving that higher efficiency figures, but nevertheless the best cabinets use less than 1/3 of the energy per unit volume compared to the average in both the chilled and the frozen cabinet types. So the best performers really are very much more efficient than the average. There is certainly a complex set of products within this overall category of refrigerated retail display cabinets. Remember that we've only picked on 2 particular subtypes, but even within those 2 subtypes we do have quite a complex set of differences between regulations and between data sets. And so comparison between the regions is challenging and has resulted in only a illustrative quality category being applied to them. And unfortunately some of the trends are inevitably skewed or masked by some changes in the scope and specification of products over the time of the analysis. The rules of the regulations have been changed in several cases over that period as well. So thinking in terms of future regulations in this area, future product policy, there does seem to be a good case for harmonization of the test methods and the policies in order to increase competition between the different areas by making it much clearer what the energy performance is relatively between the regions, between the countries. Better harmonization would also enable more effective monitoring and enforcement of the regulations by sharing data, sharing performance information about particular types of product and particular models of product. And we would hope to see, as a result of that transparency, efficiency benefits being transferred between the different markets as technologies become more clearly superior for the different types of cabinet for the different regions. So that was a summary of the results of the benchmarking report for refrigerated retail display cabinets. The full report is available on this website that you can see at the top of this slide, and also at that website you will find the individual country reports on the display cabinets for each of the participating countries, which is in less detail than the overall than what you've seen in the benchmarking, but does look very specifically at the performance and the policies in each particular country alone. But you'll also find reports on a wide range of other products for which benchmarking analysis has been carried out, and those are listed on the slide here. And if you have any If you do have any questions regarding the results that you've heard about, or any of the other products that we've mentioned studies on, then please do drop us a line. We'd be pleased to hear from you. Thank you very much for listening, and I hope that you'll look out for future reports on product policy from the Mapping and Benchmarking Annex. Thank you.